Good evening. Tonight we have a Dell Latitude E74, a Dell Latitude E7240. And the problem on this one is it says adapter unknown. Now, I did some looking into this, and just get that light out of the way. And I found a burnt chip on the board, and I presume the embedded controller EC Super IO chip is faulty. What I'm not sure about is, does this chip need programming? The chip number is a MEC5075. As you can see, it says AC adapters unknown. Now, I did try a few other adapters. They all do the same thing, and I've got a good suspicion that it's definitely the EC. So let me switch this off, unplug the screen, and let's see what the ID pin on the charger is doing. Now, the ID pin tells the laptop which charger is plugged in, so it can know how much power to use. So it's a 60 watt or 90 watt or 120 watt or 180 watt power supply. It will tell the charger, can it allow to charge a battery and run the laptop, or just run the laptop and not charge a battery. So let's get started. Right, so got a schematic downloaded, and we are under the microscope now, which I can show you more detail of what's going on. So let me see. Right. So you got the two red wires, which is positive, and then you got the black wire here that is ground. This one is ground, and then the blue wire is the ID chip. Now if we go down to the plug, we have a look for the blue wire. It's this one going to this pin number 1. So if I take the multimeter probe, put a red on ground, and plug in on the first pin, I get a normal reading, which is strange. Okay, that pin goes over to PU11, PQ2. Now let's make sure. I think it's maybe PQ2. And as you can see, that one is shorted, and I'm sure that this goes there. Let me just have a look quickly on the schematic. Right, so we've got just trying to find there we go. So the chip we're interested in is in this one over here. The KBC MEC 5075. So that's on page 37. Let's go to page 37. Right. So go on. I'm just looking for the ID pin that should go to that port. Is that system ID? I think it's system ID. Let's just see if that is the one. System ID. No, that's not the one. PS ID. PS ID for power supply ID. There we go. So that's PU111. That is this little IC on here. So what I did is I removed that chip because that chip is burnt. I think it's still here somewhere. Now pin 1 so this chip allows to switch between the dock ID. So if you dock the laptop on the docking station, to get the ID from the docking station or the ID from the power supply. So removing that chip, and putting in this jumper over here, make sure it will only read it from here. But if we go back to schematic, we will see that pin 3 and 4 is connected together, and pin 3 is actually shorted to ground. So this is pin 3, and that is definitely shorted to ground, and it cannot be. I mean, it's supposed to give the chip the ID. So that goes to, so switch this on. That goes to the DC in jack. Pin 1 goes through a coil, goes through this MOSFET. After the MOSFET, it goes to this chip. If I remove that jumper, and that will isolate the one side from the other side. So what I mean is, we can check everything before. Just get this lined up. We can check everything before this NBPS ID line up until up until this chip here. So if I remove that that jumper I put on there, that should tell me on which side the short is. So I'm just going to remove that jumper, spin it out of the way. Now let's have a look. Pin 4 is system side. One, two, three. So this is pin 3, and as you can see, there's no short on pin 3. But if I go to pin 4, which is on the system side, there's definitely a short. So I'm just going to put that jumper back, and then we're going to follow that line back and see where it goes to. I'm pretty sure that line is going to the embedded controller. So PSID, copy, paste, goes to MEC505. So definitely a short, and there's nothing in between that PSID line and that IC, that switch IC. So like I said, this is pin 3, this is pin 4. Pin 3 is not shorted. I don't think I captured that, so let's just do it again. Let's just remove that jumper. This is pin 3. As you can see on the multimeter, there's no short, but pin 4 is shorted. So that pin 4 goes directly into the embedded controller, Super I/O chip, whatever you want to call it. It basically does the low level system of stuff. Checks that the power rails on, interface the keyboard, check if the power is good from all the rails and so forth. The only thing is, I'm not sure if this chip needs to be programmed. I do have new ones all the way from AliExpress, so let's remove this chip and see what happens. Let's see what, while that's heating up, which pin is that? A55. A55 49, so it should be on this side. So let's have a look. A49, 50, 51, 52, 53, 54, 55. At least that's not 55. 51, 2, 3, 4, 5. There we go. That's definitely short enough. I think if I go back to that IC right in the beginning, Yep. So the EC chip is faulty. There is no two ways about it. So what I'm going to do is put some flux. I'm going to remove this chip. We're going to test to see if our short is gone. Noting the orientation of the chip, bottom left corner. So let's heat it up. This chip do have a funny array. I'll show you when it comes off. There we go, starting to lose up. So it's got two sets of rows of pins. You look in the bottom of the chip, it's got 2 rows of pins. So I've never done one of these. This will be my first time. Like I say, I'm doing this for pretty much 19 years already, and this will be my first one. So I think the easiest way, instead of finding that whole little thing, is to see if the short is gone. And we are open circuit. That means our short is gone, and definitely the short is in the chip. So let's get this cleaned up. Add some leaded solder, a little bit more flux, and pick up those pads, and hopefully this chip doesn't need programming. If it does, I'll have to find a way to program it, and then we can come back to this. This laptop is not a customer's. Laptop. It's actually a looking for my solder braid and I can't find it. Yeah, let's use this big one. That's strange. Should be here somewhere. Anyway, can use this big one. Oversized for this job. Clean up all the pads. This blade is no good. Let's see if we can find my proper braid. And it's on the floor. Don't know what it's doing there. This will look much better. Right. We don't want too much solder on the center pad. We're just going to add tiny bits. And that should be enough. And then pull on these. That's it. Okay, let's take one of these new chips. New. There you go. These are a little bit oxidated, so what I'm going to do is move that out for a moment. Just back into focus. I'm just going to put some flux in here, and I'm just going to clean these pads up. So those top few, you see those pads. There we go. That looks much better. Alright, I'm going to take off all the solder here. Okay, that looked better. Let's get a little bit alcohol. Clean this chip off. That looks much better. Right, so get the board back on the microscope and clean some of this flux off. Okay. Let's dry this all up. And apply flux again. Okay. You can sit a new chip on there, that little pin in the bottom. You can sit this flat. It's quite nice that this board actually have lines around the chip. It should make it easier to line the chip back up. So let's heat the board a little bit. Come on. That looks good. Just gonna clean these pins up a little bit. Apply some more solder. Right, let's add some alcohol, clean up this flux. Like I said, I hope this chip is not programmable, because this machine won't start. Okay, so Let's see if our short is gone. And our short is gone. Now the only question is, will it power up? Get an orange light, that's a good sign. Okay, let's switch back to the other camera and okay, so let's plug in. See if we actually start up the board. Let's see how we're gonna do this. Okay, get that wire out of the way. Let's get a keyboard plugged in so we can check the BIOS, and we need some power. Okay, and let's switch it on, see if it starts up. That doesn't look too good, which means this chip will need to be reprogrammed. Let's try one more time. Okay, let's just try one thing more. Come on. Nothing that side. Yep, seems that this chip needs to be programmed. I'm going to take it off one more time and just check how that solder joints are doing. Let's unplug this, move this out of the way. Just go back under the microscope. I just want to see how that solder joints fade. Could be that we had a bad solder joint. This chip could be faulty. It's all the way from AliExpress, so it's not impossible. I've got a sneaky suspicion that this chip needs to be come It doesn't actually look too bad. Drip around. It's got more solder. So what I'm going to do is add some more, a little bit more solder. Also, I just want to check that that pin is taking solder. Looks like it. And let's just refresh this a little bit. A little bit too much flux the first time. So let's just try this again. The pad will only take that much solder. Okay. Let's put this chip back. A tiny amount of flux this time. Line it up. And let's get the board warm. That looks much better. Okay. You take the soldering iron. Let's untangle it here. Untangle it. That's probably the right word. Just want to see. Slightly up. I think I released it too quickly. Okay. A little bit more solder on this corner here. So okay, clean that flux off again. Clean that flux off again. Right. So we're going to need to find out how to program this chip. Hang on. Let's give it a few seconds. Go light this on. Staying on now. But I'm interested in to see what's that voltage on that that line. Okay, stays on. Chip is not warm. Alright, let's switch it off. Plug in that screen again. That doesn't work. Need to see how to program that chip. So on, off, on. There we go. So it wasn't soldered properly. Okay, let's see if it actually sees the charger now, because that was the main problem with this system. Battery information, there we go. Let's see if we can see that. Let's just zoom in a little bit, and there it is, 65 watts. Alright, I'm gonna maybe I'm just plug in a battery, see if it charges the battery up. If it charges the battery, then our work is done. It's not installed. Let's give you a few seconds. Excellent. I'm just holding the battery. The charging light is on. As you can see on the board, the orange light is on. So see if that percentage goes up. If it goes up to 1%, I'm going to switch it off, assemble the laptop, and we'll get back to it when it's all back together. So I'm just going to leave it a while and switch off the noisy stuff. I don't know if this says charging. Give it a few seconds. I'll also do a BIOS update after the machine is back together. There we go, that's 1%. So make sure that it updates all the chips on the board and they've got all the same firmware versions. You may run into some problems if you don't do that. So this will be it. When we get back, we'll have it assembled again and do a BIOS update and see what happens. Okay, so it's all put back together again. We're back into the OS and I'm going to do a BIOS update. Let's see how it goes. Keyboard is working, mouse is working, battery is charging, it detects the charger now. So it seems that those chips don't need to be programmed. Let's see if it's going to do a BIOS update. So I think what happened is that chip wasn't soldered, that one pin wasn't soldered on properly, and I think after resoldering it, it fixed the problem. So it's updating the ME region now. updating the EC BIOS. So that's that little chip that we replaced. I still think it's got an external BIOS. There, update successful, rebooting. Let's see. Let's go back into the operating system. There we go, reboot. Switches off, switches on. Starting Windows. And that is it. Sound works, batteries charging. Let's see, 54% plugged in and charging. So that will be it for this video. Please like and subscribe, and thank you for watching.